Hi, I'm going to give you a little bit of help for what happens if we are scaling a diagram in 2 dimensions. So what we have is a nice cylinder here. I've used the formula that I found from the top of the document. And in the problem it says let's have the radius represented by x. So I've changed this from an r in the formula to an x in the diagram. What's a little unusual about this is even though I'm going to scale in 2 dimensions, and you may think it was only one because I'm only going to change the radius. And you think, well, there's only one radius here that we're using. But in the formula, we're actually using the radius twice because we're squaring it. And so that counts as 2 dimensions. So I'm going to take this opportunity to rewrite the formula just a little bit. This should help later on. Just do r times h. Let's say we're going to take the radius and we're going to make it 3 times larger. So we'll have a scale factor of 3. So the original x then will become 3x's. If I try to find the volume of this cylinder now, the scaled volume is pi times the radius, which is 3x, times a second radius, which is also 3x because I'm squaring the radius. And the height hasn't changed because I'm only scaling the radius. So I've scaled these 2 dimensions, and you can see if I rearrange these values, this is 9 pi x squared h. The h is the height of the cylinder, the x squared was the original radius squared, and the 9 is coming out of increasing the size of the radius 2 different times, and we're multiplying those or squaring those. 3 squared is 9. So the new volume is 9 times the original volume. If I were scaling 3 dimensions, maybe I'm going to continue to use a scale factor of 3, but not only will I make the radius 3 times larger, I might make the height 3 times larger. What that's going to mean is my new scaled volume, I still have pi at the beginning. The first radius is 3x, the second radius is 3x, and the height is now 3h. If I rearrange this, you can see that I'm going to have 27 pi x squared h. My new volume is 27 times the size of the original. So here is scaling in 2 dimensions. When you have an item like r squared, even though it looks like just one variable, it counts as 2 dimensions. In some volume formulas, we have an r cubed for spheres. So if all I do is change the radius, even though that's one measurement, it would actually be cubing in 3 dimensions because I'm using the radius 3 times.